Dear students, in this video, I am going to explain about lesson number 2, Quantum Mechanical Model of Atom, topic number 11, Shapes of Atomic Orbital. Already in previous video, we discussed about Schrödinger wave equation, which is the equation which purely depends upon quantum mechanics. So this is the Schrödinger wave equation, that is dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou z square plus 8 pi square m by h square into E minus V into psi, which is equal to 0. Here, by knowing the E value, that is the total energy of the system, and psi is nothing but the wave function, we can able to get some solution from the Schrödinger wave equation. While solving this Schrödinger wave equation, we can able to get some solution. That solution gives the permitted energy values. That solution gives the permitted energy values. That permitted energy value is called as the eigenvalue. Permitted energy value is nothing but the value that gives information about the exact location of the orbit and orbital from the nucleus. And the wave function corresponding to the eigenvalue, the wave function corresponding to the eigenvalue are called as atomic orbital. What is called as wave function? Wave function is denoted by the symbol psi. We assume that the electron in an orbit is traveling in the form of wave around the nucleus. Okay, that wave may have some amplitude. Amplitude means the height. Crust, crust and trough makes a wave. And the crust in the height amplitude. For example, if a wave is like this, we will have the amplitude, very small amplitude. Suppose the same wave, if it is present like this, we will be having the amplitude in a very large way. So, upon the amplitude, the wave function psi. So, based on the amplitude, the wave function will get differ for each and every orbits. So, the wave function gives the corresponding to the eigenvalue gives the atomic orbital. Okay, the solution psi, the solution wave function from the Schrödinger equation for one electron system like hydrogen, He plus, lithium 2 plus can be represented in the following form in spherical coordinates, that is r, theta, psi. What is called a spherical coordinate? Come to the next diagram. So let us take this diagram as a spherical polar coordinates. Already in mathematics we have learnt about the Cartesian polar coordinates. The same thing here we are going to see for spherical polar coordinate. Now let us assume this point x as an electron. This electron is located at a distance r from the nucleus. This is the nucleus, and from the nucleus the electron is located at a distance r. Okay, the radius of the nucleus and the distance between the nucleus and the electron is given by the radius r. So this is called as r. The angle between the radius and the z-axis. So here the electron is located with respect to three different axes, x, y and z. Okay, the angle between the electron and the z-axis with respect to z-axis gives the theta. The angle between the electron and x-axis gives the psi. Angle between the electron and z-axis gives theta. Angle between the electron and the z-axis, x-axis gives the psi. So by having three values r, theta and psi, so these are called as the spherical polar coordinates. By having the three values r, theta and psi, we can able to get the wave function for the particular orbit. The wave function with respect to r, theta and psi is equal to r of r into f of theta into g of psi. What is r of r? R is nothing but radius. R is nothing but the radius that are the distance between the nucleus and the electron present in a particular orbit. What is r of r? The density of the electron wave at a particular distance from the nucleus. Density of the electron wave at a particular distance from the nucleus. Nucleus kum electron ku undana distance r nu solrom. Nucleus kum electron density ku undana distance. And the wave form la pogumbodhu electron travel agumbodhu it creates a density, electron density. And the electron density ku nucleus ku undana distance நம்ம என்ன சொல்றோம்? R into R அப்படி சொல்லி சொல்றோம். Okay, this R into R is nothing but radial wave function. Okay, we are measuring the wave function with respect to radius. So it is called as radial wave function. What is f of theta into g psi? It is nothing but angular wave function. அதாவது இந்த பர்டிகுலர் எலக்ட்ரான் எந்த ஆங்கிளில் இருக்குது, நியூக்ளியஸ்லேருந்து எந்த ஆங்கிளில் இருக்குது அப்படிங்கிற மெஷர் பண்ணுறது பேர் ஆங்குலர் வேவ் ஃபங்க்ஷன். இட் இஸ் given by the symbol f theta into g of psi. So by multiplying the radial wave function and the angular wave function, we can able to calculate, just by multiplying the radial wave function and angular wave function, we can able to calculate the wave function with respect to r, theta and psi of an electron at a particular point. Okay, so just by calculating these things, we can able to bring out the, after calculating psi means wave function. After calculating through this equation, we can able to calculate the psi value by squaring the psi value. What is square of the psi? Psi has no physical meaning, just it indicates the amplitude value alone. What is psi square? Psi square is nothing but the probability of density of electron located from the nucleus. நியூக்ளியஸ்லேருந்து எவ்வளோ தூரத்தில் ப்ராபபிலிட்டி எலக்ட்ரான் டென்சிட்டி லொக்கேட் ஆகிருக்கு அப்படிங்கிறத மெஷர் பண்ணுறதுக்கான வேல்யூ தான் அது psi square. So if you want to know the psi square, we must want to know the value for psi. After calculating psi, it should be squared. If it is squared, the psi square value will be obtained. Psi square value directly denotes the electron probability density around the nucleus. So in order to calculate psi square only, we are calculating psi in this particular first expression. Now we know psi, the wave function, has no physical meaning. Already in the previous video itself we saw that psi has no physical meaning. It provides only the amplitude value. But square of the wave function, that is psi square. Psi square means the probability of finding electron within a given volume of space. Let us analyze how the psi square value varies with the distance from the nucleus and the direction from the nucleus, that is angular distribution. With respect to radial distribution probability and angular distribution probability, how the psi square value is going to be differ. That is what we are going to see in this particular shapes of atomic orbital topic. So in the next video, we are going to see each and every orbital by taking individually. For example, oneness orbital we will be discussed separately, 2s, 2p, 3s, 3p, in such a way we will be discussing. And at that particular time, we can able to calculate, we can able to see how the psi square value varies as the distance between the electron and the nucleus and the angle between the electron and the nucleus get differ. Okay, now let us come to the oneness orbital. As I told you earlier, the probability density, it is very clear from this diagram that the probability density of electron is very higher nearer to the nucleus. Now the point where the two axes meets contain nucleus. The point where the two axes meets contain nucleus. So here is the nucleus. Around the nucleus we can able to see, or very nearer to the nucleus we can able to see the more density of electron. So the probability of finding electron in oneness orbital is high nearer to the nucleus. What happens as the distance increases from the nucleus? As the distance increases from the nucleus, the density got reduced. The probability density of electron got reduced around the, for example, after some distance from the nucleus, we can able to find only less probability of electrons. So oneness orbital diagram shows the maximum probability of electron lies nearer to the nucleus. What about 2s orbital? 2s orbital we know very well. At the nearer to the nucleus we will be having a oneness orbital. After oneness orbital some space will be left, and after that space we will be having the 2s orbital. Okay, so oneness orbital is nothing but the probability density that is lying nearer to the nucleus. After that some empty space will be there. That empty space may be called as a node. This empty space where the probability got reduced is called as the node. Okay, after the nodal surface, once again the probability density got increased. The second increase in probability density refers to the presence of 2s orbital. Okay, so how many nodes are there in 2s orbital? Only one node between the oneness orbital and 2s orbital. Between oneness orbital and 2s orbital we have a less denser electron density area, that is called as nodal surface. Next, coming to the 3s orbital, as like that of the 2s, at the nearer to the nucleus we have more density, that is nothing but oneness orbital. After oneness orbital some space is there. After that we will be having the next electron density is found, that is nothing but 2s orbital, and after that some empty space is left. Two empty spaces are here, so both are called as nodal surface or nodal plane or nodal point. After the 2s, we have some nodal surface, and after that we are having the 3s orbital. So here how many nodal surfaces are there? 2 nodal surfaces are there. So what is the formula to calculate number of nodal surfaces? N minus 1 is the formula to calculate number of nodal surfaces. So for example, if 2s orbital, what is the n value? N value will be equal to 2. So 2 minus 1 is equal to 1. One nodal surface will be there for 2s orbital. One nodal surface will be there for 2s orbital. Yes, it is correct from the diagram. Similarly, for 3s orbital, n value will be 3. 3 minus 1, which is equal to 2. So 2 nodal surfaces are there for 3s orbital. Yes, it is also correct from the diagram. So this is the method to calculate the number of nodal surfaces present in any of the orbitals. Thank you.